Alright, Art22, welcome back. Today in this video we are going to be talking about dealing with images and shapes in processing. So far we've looked at mainly just the 2D primitives that processing offers us, rectangles, ellipses, points, but we can also import our own images from wherever, as well as something called an SVG, which we'll get into. And so today we're going to look at how we can import those into our sketch and then use them and resize them and all these good things to make them move around. So let us jump into it. Oh, one other thing, we're going to be also looking at the random function, which is something that we'll use a ton in this class. And even in the next lecture, we'll see it in a very interesting way. But today we're just going to get used to how we can create randomness in our sketches. And that is all we'll focus on today. So let's get into it. Okay, so I have a sketch here. Week 2, Class 1A. We're going to have 2 sketches for this first class this week. And so what our goal is going to be is we're going to import an image as well as an SVG file. And then we're going to work with those a little bit. So let's go ahead and get the things that we always have in our sketch set up, which is our setup section and our draw section. So let's get that going. Void setup. Void draw. Okay, that's looking good. So anytime that we want to bring in files, whether it's an image, whether it is a sound file, it could be a table like a CSV, like something you'd see in Excel. Anytime we do any of that, we need to do something a little different to our the area where our sketch is saved. So if you remember, we can go to Sketch and then Show Sketch Folder, also Command K, and that's going to show us where things are saved. I'm sorry, where our processing sketch is saved. And so what we need to do is create a new folder called Data. And this is where we're going to store anything that we're going to bring into our sketch and use. And so in today's case, and I have these up on the class GitHub, we are going to be working with this image here and this SVG here. Now, an SVG stands for Scalable Vector Graphic. It's basically a graphic that you can resize, and it's not going to get all pixelated or lose quality like a normal image file might. Hence the word scalable as part of the extension of its file name. So we're going to use this ghost and this image. Now, we're going to have to set up a size for our sketch. And because, at least for now, I want the entire sketch window to be the same size as my image, I'm going to look at my image size down here. And I notice that my image is 1500 by 938 pixels. That's the dimensions right there. So when I make a size for my window in our sketch, I'm going to use those numbers just so that it matches with the image. We're going to see in a little bit how we can resize this image, but this might be a nice starting point, just because those dimensions are actually pretty nice for what we're looking to do today. So now that you have a data folder next to your sketch with our images in it, we should be good to go. So let's just quick recap of our file structure in general. You should always have a folder with your sketch's name, the actual sketch, the .pde file with the same name has to match. And now we're going to have this data folder that contains anything we're bringing into our sketch. Okay. So I said that the size of our sketch It's going to be 1500 by 938 pixels. There we go. Okay. So now let's go through the process of actually importing these images into our sketch. So in the same way that when we were making variables in previous lectures, we can declare the type and then the name of that variable up here at the top. In processing, if we use an image, we can say p_image as the type, and we see that it turns green, so everything is happy. Okay. Let's grab this over here and move it out of the way. So p_image is the variable type for images in processing. And now we can give it any name we want, just like how when we had an integer, we could call it anything, x, banana, whatever. So in this case, just to keep it clear for our own brains, I'm going to call our image img for image. Okay, we'll come back to the ghost SVG later, but let's just stick with the image for now. All right, so we have an image variable called img. Now what we need to do is actually set this variable to be equal to our image that we want to use. So how we do that is we say img equals load image. And now we just have to give it the exact file name of our image we want to use, and we put it in quotes. So I'm going to say desert.jpg. There we go. So here's another built-in thing that processing gives us, and then we just have to tell it what file we want. And now image will be associated with that desert image. Okay, now just to prove that that worked, why don't we come down here to our draw loop and actually draw this image? So there's thankfully another processing function built in for us to do that, which is simply image. It turns blue. That's a good sign. Now we have to tell it three things. We need to tell what image do we actually want to draw. In this case, we want to draw our img image, the one that we just set equal to our desert photo. And now we have to tell it where do we want the location. The location is going to be based on the top left corner of the image. So in that case, we need to think about where we want to place this image in our window so that it fills up the whole space. So if we're going to be placing it based on the top left corner, we want that to be also in the top left corner of our window, and we know that that is 0, 0 because that's where our origin is. So we can actually just say 0, 0. Okay, so let's give this a run and make sure everything's working. And as always, mine jumps to the other screen. And this is actually a little bit big for my screen, but you can see that things have been placed correctly. We said top left corner, put it at 0, 0, and it did, so that's good. And yeah, things are looking good. Okay. All right, so now let's, before we do anything to this image in terms of reshaping it and all that good stuff, let's go ahead and take a look at that other image we were checking out, that ghost.svg. Now there's a small difference between the variable type between the SVG and a normal image file, like a JPEG or a PNG. There's a bunch of them out there, but those are the two most common, I'd say. So instead of a p_image, the variable type for an SVG is a p_shape. And then we just need a name for that variable, so let's just call it S for shape. Okay. Now beyond that, things are very, very similar. So instead of loading an image, we're going to load shape. So we can come down here and we say this time we want to load our ghost.svg into the variable S. So we'll say S equals load shape, and then we just put in the file name ghost.svg. And now in the same way that we used the image function to draw an image, you guessed it, we used the shape function to draw a shape. And then the same, we call these, the things that go inside here, inside of, when we make a new function, these things that go inside of here are called arguments. So shape wants 3 arguments as well. It wants the variable, the shape that we want to draw, which in our case is s. And the last 2 arguments are, again, the location. So instead of putting it at 0, 0, why don't we just put it at the middle? If we remember, we can say this for the middle, right? Width divided by 2, height divided by 2. Okay, so let's see what happens there. Okay, so a little bit of an issue here, right? Our shape is gigantic, but we can work with that. But everything else is looking not too bad. Okay, so let's talk about how we can resize things with our image and shape function. So let's keep our image the same for the moment, but maybe what we want to do is make our shape, our ghost shape, quite a bit smaller. So we could just tell it exactly what dimensions we want it. So we can add 2 more arguments here to the end of our shape function, which are the width and the height of how we want to draw the shape. So in the same way that we did this for rectangle and ellipse, we can just tell it what are the dimensions we actually want this shape to be. So we could give it some, hard-coded numbers. Hard-coded just means like, a number, not a variable, which, as we've learned before, works, but it's not very flexible. But let's just do that for the moment. So let's say we want our shape to be 200 by 200. All right, let's see what that gives us. Okay, there we go, much better. So now we got our ghost, that's 200 by 200, floating around by the tree, and things are happy. Okay, now I kind of had a bit of a leading thought there, which is to throw some shade on hard coding numbers here. And the reason is, I think it's always better to use variables when possible, because that way when you change things later, you don't have to worry about updating numbers. If you remember, that's why we use this to get to the middle, because if all of a sudden I change the size of my window, I don't have to change anything about this. It'll automatically find out what the current width is and what the current height is and divide it by 2. Now we can do the exact same thing for shape. So let's say that instead of just putting 200 by 200, we wanted the shape that we draw to be, how about half the size of its normal dimensions. So what we can do is say, instead of just width and height, we can say s dot width. So the dot here is acting as kind of a reference or a way to associate this width. We want not the width of our entire window, but we want the width of s, which is our shape. So s dot width, and we said we want it to be half as big, divided by 2. And then s dot height divided by 2. Okay, let's take a look at that. All right, there we go. You can see that we're half of the original size, or at least you can trust that that's working. Maybe it's a little bit too big still, so I'm gonna go, how about, let's make it a quarter of the size. S dot width divided by 4, S dot height divided by 4. I feel like this is gonna be a bit better. Okay, yeah, that looks pretty good to me. All right, so the nice thing about this method of resizing things is that it can be applicable to images as well. So we could say that we want to draw our image, maybe still at 0, 0 in that top left corner, but maybe we want our image to be half as the size. So just like we said s dot width, we can now say img for our image, dot width divided by 2, and img dot height divided by 2. Let's just check that out. Okay, and there we go. So now we've scaled our image down by half, and we still have our ghost floating around over here. Okay. All right, let's do 2 more things with our images here before we move on to this idea of using a random function. So let's say to make this slightly more interesting, I'm gonna bring this back to its full size. So if we don't put an argument in here, if we don't put any of these last 2 arguments in, it's going to, by default, draw the image at its full normal size, which was that 15 by 938. Okay. But now what I want to do is have the ghost moving around in some way. And we saw last week that we can use our mouse as a way to interact with objects on our screen. So let's go ahead and do that. So we can keep it the same size. I still want it to be 1/4 of the size. But instead of putting it at width divided by 2, height divided by 2, I'm going to put it at our mouse location. So mouse X, mouse Y. All right, let's check that out. Okay, and now we've got our floating ghost hanging out. Again, there's a little bit of a delay based on all the screen recording I'm doing. But there we go. We have our desert ghost, Lord of the Sands or something. Okay, so this is not the most compelling art piece we've ever made, but let's pretend it is for the moment. And let's say you're like, oh man, this is it. I need to maybe take a screen grab, maybe take a screen video, maybe export all the frames so I can have this as an animation, which we'll look at how to do that in a little while. But this is what I want. But what I don't want is that ugly cursor kind of throwing things off. So let's look at how we can get rid of that if we don't want it. So we draw our image in this first line. Maybe let's get a couple comments in here. Draw image at full scale. Wow, scale. I'm going to say load images and shapes. Okay. Draw shape at mouse 1/4 scale. Scale. All right. And now, because we don't want that ugly cursor messing with our beautiful composition, we can give processing another built-in function called noCursor. And what that's going to do is just going to hide our mouse, which for this is kind of what we want, I think. And there we go. Now we're just zooming around with our ghost here. No mouse to kind of, ruin our suspension of disbelief. And that's that. Okay. So hide mouse. All right. So that's where we're gonna leave it for the moment with images and shapes. In a later week, we're gonna get much deeper into how we can start manipulating these images and shapes. And start messing with their pixels and do some pretty cool shuffling around of things. But for now, I just wanted to talk about how we can actually import this type of stuff into our sketches. Okay, so the last thing we want to do today is look at the random function. So the random function is going to be our first taste into how we can start having the program or our computers making some decisions on its own. So how can we start to automate our sketches? And we're going to see that this is going to become a very powerful tool in a lot of what we do, because all of a sudden we are no longer having to control everything. As of right now, I have to move my mouse around for things to move on the screen, or I have to tell it to, add a few numbers to the rectangle's position, and it kind of moves in a predictable way. But if we want things to start being, less predictable and more interesting and more complex, we can embrace this idea of using randomness. So thankfully, processing has a random function built in. So what I'm going to do is come back up here to the setup section of our code. And what I'm going to say, actually, first things first, let's get a variable that's going to get assigned a random number. And we're going to switch it up on you a little bit. So in the past, we've used int, which was an integer, which means a whole number, so no decimal point. But if we want there to be a decimal point, we can say float. So a float is going to be a number that has a decimal point. So for example, floats could be like 4.2 or 3.0 or 199.78. No, that wasn't an 8, but you know what I mean. As opposed to an int that's just something like that. Okay, so let's make a float called r for a random number. We'll say our random number. Okay. And now I'm going to come down here and I'm going to say r is going to be equal to random. So this is processing's built-in random function, turns blue. Good things are happening. And now what we need to do is give processing a range of our random numbers. So maybe right now, let's give it the range 0 to 10. Okay. Let's just, we want to see this thing, right? So let's go ahead and print it. We're going to say print r, print line r. Okay, so here we go. We have 4.857406. So that is the random floating point number, the random float that this function gave to us. Just to prove this point, let's run it again, and we'll have a different number, I'm sure. There we go, 2.13354. Great, things are good. All right, so two things to mention about the random function. I mean, there's a lot we can mention, but we're just going to stick to two right now. First things first, we gave it this range of 0 to 10. Now what we need to know is that 0, by default, if we give it two arguments, two things inside of the parentheses, it's going to say 0 is our lower bound, but it's going to include that lower bound, so we could possibly get 0. However, 10, this upper bound, the way that random works is we're going to go up until 10, but not including 10. So if we actually wanted to get numbers between 0 and 10, we should say 0 to 11, because it's going to go up until this number, but not include it in the possible random numbers that we get. We'll see this a bit more clearly in a second here. So I'm going to go back to 10. And the other thing I want to mention is, maybe we don't want all these decimal point numbers after the dot. Like maybe that's too much. We just want kind of nice whole numbers. So luckily with processing, we can change a float into an int and basically chop off all that stuff on the right very easily. So let's do this. I'm going to make an integer variable, and I'm going to call it int r. So this is the integer version of r, our random number. So integer version of random number. So now what I'm going to do, so we've assigned r a random number between 0 and 9 really, right? Because we're not including 10. But we don't want all that garbage on the right side. So we're going to say int r is equal to int of r. So int here with parentheses is a little function that's going to take a number, in this case, that floating point number r, and it's going to force it to become an int. It's going to say, hey, 13354, I'm just going to chop all you off, and you're going to become 2 now, or whatever the number is. So let's look at that real quick. So I'm going to print r and int r. Let's see what we get. Okay, there we go. So the float version, the decimal version, was 5 point a bunch of stuff. And then our int version was like, yeah, see you later, just 5. Maybe a cooler way we could have printed that. Remember, we can put multiple things on one print line. So we could say something like r and int r. Let's see what that gives us. Okay, now we printed them both on the same line. One thing I really like to do if I'm printing stuff that I need to try to understand what's happening in my code is I give a little bit of like a text clue to myself. So I'll say something like this. So if you ever want to actually just print some text, you can put it in quotes, just like we did with our file names here. So what I'm going to say is random float. So you notice that I left a little space, so now there will be a space between this text and when we actually print that. And now I'm going to say comma space random int. So let's look at the way I formatted this and how it comes out on the other end. Okay, there we go. Random float space random int 1. So these are just some strategies to make things a bit more legible when you're printing, because you can imagine if you're printing a whole bunch of numbers for whatever reason, it might be hard to remember like what exactly, like what's what when you're printing a bunch of stuff. So adding little text in here can really be helpful. Okay, so that's basically what we're going to deal with today in terms of images and randomness. We are going to see in the next lecture how we can use randomness to our advantage to make to really start to unleash the power of computation in art. And so we're going to be combining randomness with our new concept, which is one of our trickier concepts for the entire quarter, which is why I'm introducing it early, which is something called the for loop. And so we'll talk all about that next lecture, but we're going to start to see some more interesting, complicated things. So stay tuned.